Thank you, Dave, for the intro, and I'm excited to talk today about investigating emails altered on the server. Just a little background. I'm the founder at Metaspike, where we develop digital forensic software for the cloud with a focus in forensic email preservation. I'm also a forensic email examiner, generally a forensic examiner that does a lot of email investigations. So email forensics is near and dear to my heart. And this presentation is actually partially based on real life scenario that I encountered. So I'm going to give you a little bit of backstory on that first before we get into the slides. So let's go back in time by a few years, let's say 5 years, and meet a forensic examiner. Let's call him Jim. And Jim is a great guy, very experienced forensic examiner, and he's retained by a law firm to forensically preserve some emails. So they tell him, hey, we need you to connect to this AOL mailbox, collect a few relevant emails, not the whole thing. This is not really a forensic investigation at this point, just a disclosure exercise. So we want you to collect these emails. They might be important later on. So he does that. So what he does is he actually sets up his Outlook. He gets the credentials from the end user, connects to the AOL email account, lets Outlook do its thing and sync the emails, and gets a local Outlook data file, an OST file that's filled with emails from the mailbox. So the next thing he does is, because he doesn't want to preserve, or he's instructed not to preserve the entire mailbox, he takes that OST file and he puts into his favorite investigative tool. He runs some keyword searches there. He identifies those few emails that are really relevant to the legal action. He exports those out of the forensic tool as EML files and discards the original Outlook data file. So he's done with the preservation. He tells the legal team that they're good to go, and a few years pass. But now the authenticity of those emails gets called into question. So Jim's asked to testify now about those emails. And he's in a bit of a pickle because he's made a few mistakes. Number one, he did his email preservation work with Outlook, which is a general purpose email client. It allows two-way sync. So he had the potential to make some changes to the original evidence there. Number two, he collected the whole mailbox in an Outlook data file, but he didn't keep it. So he just kept a subset of it and discarded the original items that he collected. Number three, the items that he has left, the EML files, are not an identical original copy of those emails as they got transmitted from the server, because they've been through some conversions already. When he got them into Outlook, Outlook converted them, and then we got them into the forensic tool and then exported them again to EML format. So they've been through a couple of conversions, so they're a little bit different than what they used to look like. So Jim goes on the stand and testifies, and his opinion is that he says he collected these emails directly from AOL. The end user, his ultimate client, does not work for AOL, does not have access to AOL servers, so he has no way of really altering these emails that sit on the server. And he says he kept good chain of custody records. He hashed the emails, so he's confident that nobody has changed those emails since he collected them. And he's confident that the end user client does not have the technical sophistication to change those emails on the server. So he says these emails are authentic. There's no way they could have been changed. I found them sitting on the server. But there are a couple of mistakes here in Jim's reasoning. Number one, let's think about his assumption that the emails are unalterable on the server. That's not right, because an email server is designed precisely for that type of interaction. So you can connect to an email server either with an API like Gmail API or Exchange Web Services API, or through a protocol like IMAP. And in all cases, there are methods, API methods, or IMAP commands that would allow that type of modification of emails on the server. You could import messages to the server. You can copy messages around, modify them, change their flags. So there's a lot of functionality built in that allows you to actually make changes to email messages. You don't have to have special tools. All you need is an email client, really. So that's where he makes the first mistake. So in this talk, I'm going to generally cover what an end user could do to very easily alter emails that are on the server. As a forensic examiner, what you can do to preserve those emails correctly so you have all the information you need to investigate them, and finally, what you should look at to determine if there's something off with these emails, if there's something that doesn't add up. So let's start with an example. And I picked an email here that's a very simple email with a couple of lines in the message body that talks about proceeding with a transaction. Apparently has been sent July 2019, and it's from a Yahoo email account to a domain called proximity.com. And the email mail exchanger records of proximity point to GoDaddy. So the email business is handled by GoDaddy in this case. So what I did was I connected to that GoDaddy account, pulled down the whole mailbox, so I have a copy of it in my Outlook, and I opened up this very relevant message. So let's say that I have some motivation to change this message. Let's say that proceeding with the transaction doesn't really go very well with my narrative in this case, so I want to change that to say, whoever sent this message said to cancel the transaction instead. So if I wanted to do something like that with something as simple as Outlook, then I would go do this. I would go to the Actions menu and say Edit Message, and I would just point to where that part of the message body is and change it, done, and save. So let's think about what happened now, where are we at now. So this hasn't changed the message on the server yet. So all I've done now is I had a local copy of this message in my Outlook in an OST file. And when I instructed Outlook to edit it and save it, then my local copy has changed. And Outlook actually has inserted a bunch of artifacts into the message body that have to do with Outlook's formatting of the message body. It added some message headers that say that this message has been sent by Outlook, but it hasn't pushed anything to the server yet. But what happens when you let Outlook go through the send and receive cycle? So if you let it sync with the server, it does this. So if you listen to the network capture the packets with something like Wireshark, for example, and take a look at what it's doing in the background, it issues a few commands back to back. First, it issues an IMAP append command. So the append command is something you would use to add a message to an IMAP server's one of the folders in the server. You would issue the append command with some optional arguments, so you could pass a flags argument to tell it what IMAP flags you want the end result to have. You could pass an optional timestamp argument, so that affects how the end result, the resulting message has an internal date. And finally, you would pass a message literal, so that's the actual contents of the message that you want to append. So essentially what it did is, what Outlook did is it got the message that I modified, and it passed that as an argument to the append command and added that to the end of the inbox because I was in the inbox. And then it sends a command, UID store command, to set the deleted flag on this old message. So what it's doing is it's marking my old message for deletion. It hasn't deleted it permanently yet, but it just set a flag there. And right after that, it issues a UID expunge command, which actually permanently deletes that message, so it purges it from the server. So if you're like me, you might be thinking, could I get my hands on the old message? Because that would be pretty powerful. Here, there's this end user that claims the message about cancellation is the one and only true copy of the message. If you could dig up that old copy that says proceed with the transaction and present them side by side, that's pretty powerful evidence that some forgery took place. So as it turns out, if you're dealing with a plain IMAP server like Yahoo or AOL or something along those lines, or GoDaddy, then the server doesn't have any mechanism, no API methods or IMAP commands that would allow the end user or the forensic examiner connecting to it as a client to retrieve that purged message. But what if you're dealing with a more sophisticated server, like an Exchange server? Well, the good news is if you are dealing with an Exchange server, then there's the recoverable items folder. So this folder is a special folder. If you connect it to a mailbox, you'll see that a mailbox has multiple subtrees. So one of the subtrees is the interpersonal messaging subtree that holds the visible folders that you see, like the inbox and things like that. And then there's another non-IPM subtree, which one of the items there is the recoverable items folder. So this is used by some of the services like the litigation hold, in-place hold, single item recovery. And one of the folders there is the deletions folder. So this holds the soft deleted items. So essentially items that got deleted from the deleted items folder or got shift deleted directly from the mailbox to bypass the deleted items folder. So in this case, if you look there, you would see the original copy of our altered message. So for clarity, what we did here is we have a message that got changed on an Exchange server through IMAP, and then we examined the recoverable items folder and found the original copy before the modifications in the deletions folder. So this is the new name for the Exchange dumpster, essentially. So this is pretty powerful, and it's actually a very good data point to include in your email preservation. You wouldn't get the recoverable items folder through regular email clients like Outlook or connecting through IMAP, but you would access it through an API like Exchange Web Services API. And there's good reason to include that in your standard Exchange preservation workflow for getting deletions, discovery holds, and things like that. So what if, so in this case, I changed just a little bit of the message body, but what if I wanted to make some more substantive changes to my message? Like I wanted to backdate it, for example. I don't want to just change the message body. I want to roll it back a couple of years to better fit the time frame of my litigation. So one of the ways you could do that is, instead of using Outlook, you could just pull down a MIME version of that message and put it in a text editor. And then you can start editing away. You can just change the dates manually. So in this case, I'm setting them back to January 2018. The dates are in a few places, so I'm just covering all those bases. So I'm now setting up the origination date in the header. And then I'm going to scroll down a little bit to get that message body too. So change that with cancel. So in this case, I'm not using Outlook, but I'm going to use Thunderbird, and I'm going to manually upload it to the server. So I'm just going to drag my new message and drag it over to the inbox. So what happened now? Well, Thunderbird did essentially the same thing. It issued that append command and added this message to the end of my mailbox, inbox in this case. But it didn't do the rest. It didn't do the setting of the deleted flag and purging the message just yet. So if you wanted to do that, or if the bad guy wanted to do that, he could go and delete that message himself and purge it and erase copies of it. And now that we've gone through this, we actually successfully changed the message on the server, and it looks like this. So if we go through GoDaddy's webmail interface, now we have the fake date here that points to January 2018, and we have the message body that says, instead of proceed with the transaction, it says please cancel. So if somebody were to come after him and look at this in GoDaddy's webmail on the server, it looks very much like a legitimate message, but it's been altered through just a couple of simple steps. So let's think now about what we can do to get to the bottom of this, how we would effectively preserve this mailbox to get the information that we need, and what we would look at to see what, to detect this kind of malicious behavior. So as far as preservation goes, there are three key aspects to this. You need to preserve as close to the original format as possible. So when you connect to the server through Gmail API, Exchange Web Services API, or IMAP, the message comes over the wire in MIME format in RFC 5322. So you want to have a good copy of that message. In Jim's case, he didn't have that because he's already running through some conversions. And we'll see in a little bit how this affects our examination. If we don't have that good, pristine version, then there are some things that we just can't do. And then in addition to the message itself, you want to get server metadata. I'm going to talk more about this in a little bit, but this is essentially some metadata that's outside of the message, about the message. And finally, you want context. So if somebody says, hey, get this message and authenticate this, you don't want to just preserve that message. You want to get its neighbors, ideally that whole folder, or perhaps the whole mailbox if you can, just so you have some context when you're examining to look at its neighbors and see if your target message or messages are making sense when you look at them in the context of their neighbors. So server metadata, what I mean by this is information about the messages, but not inside of the message, so not within that my message itself, but on the server. So it's kept on the server, and because of that, a lot of times it's not acquired along with the messages, so you have to make an effort to go and capture that and either bundle it with your messages or keep it on the side, but have a record of it so you can do your examination. So for example, when we talk about server metadata, I like to think about the levels of access we get to email evidence. So in some cases, you might start off with just a printout of an email. Happens to me a lot of times. It's sad but common. You might have the email message in native or near native format, so essentially in the original format where it was created, or maybe some type of conversion that's derived from there. And then in some cases you might have access to the email account on the server like Jim did. So somebody gives you credentials to that mailbox and says, hey, you can connect to this and collect emails there. And finally, you might have access to the entire mail server. So it might be a friendly situation where your client allows you to just sit in front of their server. You have access to, administrative access to the server. You can examine the logs, preserve the whole thing if you wanted to. So in the last two of those scenarios, you would have an opportunity to preserve the server metadata. So for example, if we were to think about an IMAP server, a few things come to mind in terms of server metadata. One of them is the unique identifier message attribute. One of them is the IMAP flags, and finally the internal date message attribute. The unique identifier message attribute is a very cool artifact because it's a 32-bit integer and it's assigned in an ascending fashion. So that's very key. So what happens is when a new message gets added to the mailbox, it gets the largest UID number. So that puts things in perspective when you look at the messages in context. So if you have a message that has a larger UID, then that tells you, hey, this must have been created here after the other ones. And not necessarily contiguous, so there can be gaps in the numbers. So what that means is if you have a message that got deleted from the middle, the server doesn't make an effort to remove those gaps and compress the items. There are gaps and you can see them, so that gives you some clues as to what might have been deleted from where. Internal date is again a server-side attribute, so this is not something you find within the message. It's on the server, and you can think of this something along the lines of a file system creation timestamp. So usually it indicates the date and time when a message is created in a folder. Some factors affect this. For example, if you get the message directly from SMTP, so there's a message that's arriving normally as an email message to the mailbox, then you would expect the internal date to mirror the time of final delivery. So that would be the last trace field in the message header, the last field that says received and there's a date and time. The server would usually take that and put that as the internal date of that message that's coming. If you migrated this message somehow, so for example, you issued an IMAP copy command, which is similar to append, but instead of taking a message literal as an argument, it takes the ID of an existing message and it copies it from one folder to another. Then in that case, the internal date message attribute would be preserved. So the IMAP server would take the date of the original message and apply that to the new message. And in the case of the IMAP append command, which is what we used, it depends. If you issue the IMAP append command without a timestamp argument, then your internal date would reflect when you issue that append command. If you issue the command with a timestamp argument, and that timestamp would become the timestamp of the new message. So we're going to see how that plays into our investigation. So let's take a look at our message and the metadata we have on the server surrounding this message before the manipulation. So I have the message here, at least the beginning part of it. And when I look at the server, so I put the UIDs and the internal dates side by side. So when I sort by UID, I see that they're in sequential order. There are no gaps in that neighborhood. And when you look at the dates, the internal dates, they're also in chronological order. And everything is lining up, life is good. If you look at the highlighted parts, you see the last trace field up there, which is the time of final delivery, and that matches with my internal date on the server. So this is good. So let's look at this now. Let's look at what happens to this after manipulation. So after I changed the dates and times and uploaded this back to the server, now you see that the UID changed and it got a larger UID. So I have some gaps there, and after that this message got UID 931, which is higher than its neighbors. But the internal date is in 2018, and it matches the last trace field again at the top of the message. So there's a discrepancy here. You would expect that if this message has the largest UID here, it should also have the latest internal date, or something off is happening. The other alternative is if we had issued IMAP append command without a timestamp argument, then it would look like this. Now, if you look at the internal date, it matches, when you look at the internal date, it matches the time when we issued the append command, but it no longer matches the last trace field, so it no longer reflects the alleged time of delivery of this message. So there's a discrepancy here too. We have a message, if you look at the server metadata in isolation, then the UIDs are sequential, the internal dates are in cron order, so it looks good within the server by itself, but when you compare that to what you see in the message, then the dates in the message and the dates that are on the server about the message are conflicting. So you can tell right away that something happened to this message. At a minimum, it got moved or migrated. If not, it got modified somehow. So when we talk about server metadata, I don't want you to think that this is limited to IMAP only. All kinds of servers have server metadata. In the case of Gmail, for example, you would get things like thread IDs, which is what Gmail uses to decide on conversation thread. There will be label IDs, the IDs of the labels that are applied to each message. There are history records, which are pretty interesting. So these are something that facilitates easier syncing for email clients. So they would be records that indicate the changes that took place in the mailbox, and they're associated with IDs of messages and labels that are affected by those changes. So this is pretty powerful because you could look at some history records and try to correlate them with your message, and if the dates of those history activity doesn't line up with your apparent date of your message, then that could be a problem there as well. And finally, in Gmail, there's also the internal date, which is similar to IMAP's internal date. And same thing with Exchange. So in an Exchange server, you would get a large number of server metadata fields, all these mapping properties. Depending on how you preserve from Exchange, some of those properties might be in your MSG file or PST file or OST file, or in some cases, if you got it through Exchange Web Services API through as a MIME message, then those properties would be on the server, and you would query them separately, and you want to make sure you get what's relevant to your case as server metadata. So now that we talked about server metadata, let's talk a little bit about message data and metadata. So we looked at the server stuff. So this is the traditional artifacts that you find within the message, more commonly looked at by forensic examiners. So some things from the message header, like the trace fields, references field, DKIM signatures, MIME boundary delimiters, and then the message body itself. So let's take a look at our altered messages header, and let's see if we can spot anything strange going on here. So I'm going to start from the bottom and go upwards a little bit, and on the bottom I see a field called content length. So this is a field that I like having to give you a brief intro on that. So content length is a field that indicates the byte size of the payload of the message. So if the message looks like in the figure, and if the white part is the header and the yellow part is the message body that follows the header, then the content length is the number of bytes in the payload, including the encoded attachments and everything. One tricky thing about this is that when you're counting the bytes to do your calculation, you want to make sure you count them in Unix format rather than in Windows, because if you count them as 2 characters each, then that's going to throw off your calculation. So when we go back to this message and look at content length, we see 700. So that tells me that this message should have 700 bytes in its payload that starts right after that content length marker there. But when we do the calculation, we see that it's actually 688. Why did this happen? Well, if we think about it, what we did was we went in there and we removed some characters from the message body. So it originally said proceed with, and we changed that with cancel. So we replaced the 12-character string with a 6-character string. But the discrepancy here is 12 characters, not 6. So how did that happen? Well, that happened because there were 2 versions of the message body. So there's the text version of the message body and there's the HTML version. So we replaced both of those. So 2 replacements, 6 bytes each. So we made a 12-byte change in the payload. So we see one discrepancy here right away, and it's kind of a red flag. But if you think about it, you see that the content length field is actually pretty vulnerable because it's just this plain number there. And if the bad actor has any knowledge of how this works, they could very easily modify that number along with the message body too. There's nothing that prevents them from doing it. So it's useful in those cases where nobody notices and you know about it. It's Yahoo and AOL actually like to use this field, so it's good to know about it. Another thing that we spot here, which is a lot more powerful, is the DKIM signature. So the DKIM signature, again, to give you a quick intro to that, is essentially a signature that's calculated by the sending entity, in this case yahoo.com. And what Yahoo did here is it took the hash of the message body and a selection of header fields, like the to, from, subject, and date, for example, and it signed them with its private key. So we see that signature there. So what we can do as the recipient or examiner is we can go fetch Yahoo's public key from DNS records and do the reverse to verify the signature. And if the signature verifies, then we have some confidence that this message may not have been altered since Yahoo signed it. But in this case, it fails. It fails because we made a bunch of changes. It fails because we changed the body, which is part of the DKIM signature. We changed the date field, so that's the origination field. We made a change there. So all in all, the DKIM signature is not valid anymore. And this is pretty powerful because as the bad actor would not have Yahoo's private key, they would have no way of recalculating this signature. So one thing they could do is they could remove this header field to cover their tracks if they know about it. If it is within the time frame where Yahoo started using DKIM signatures, then you would know. You would notice the absence of it, and that would be a red flag itself. Hey, how come this message is from Yahoo, but there is no DKIM signature? But if they roll it back so far that Yahoo didn't used to use DKIM signatures back then that's a bit of a different story. Something else here is, this got a little bit shifted in the screen here, so you should look a little bit higher than that to the left. There's a number there, right in the, if you look at the content type header field, there's a section, the boundary that goes part, and then there's a number, and there's another number. So that's an epoch date. So there's a hidden date there, and let's think about why that happens. So there's a boundary delimiter there. And the reason for that is the MIME message has different sections. So it has the text message body and it has the HTML message body. In some cases, it might have attachments. So to separate those MIME parts, there are MIME boundaries. And when the server creates a boundary, it wants it to be unique because you don't want that boundary to be elsewhere in the message body. It would throw things off. So when servers are calculating or creating those MIME boundaries, some servers like to include the current date there. And in this case, Yahoo's server included the current date with millisecond precision in the boundary delimiter. So that's a pretty good clue. That's actually, that points to the sent date of our original message before the manipulation. So this would be something hard to explain for the bad actor. How come there's a date from 2019 there when nowhere else in the message do we see that? And when you look further, there are two more, again shifted a little bit, but we see the same date in the message ID header field and in the references field. It's about the same number, but 1 millisecond later. So this ends with 410. So just 1 millisecond later. So this is created when, again, the server calculated assigned the internet message ID to that message, which is, again, something that should be unique. So there's benefit to using the current timestamp there. Let's see if there might be anything else that I'm missing. And one more thing where this epoch date is hidden is in the DKIM signature, right where it starts with, not where it's pointing right now, it's shifted a little bit, but where it starts with T, the T tag there. So the T tag is a number again, and that's the timestamp when the DKIM signature was calculated, and it's supposed to match this receive date in the header. In this case, it doesn't match anymore because we modified that receive date. So we got a few flags here. If we scroll down further to the message body, again, we have a few boundary flags there, all with the same epoch date. So things are not looking very good for this bad guy. So we got quite a few clues from the altered message body. So if you think about DKIM verification, you might think, hey, this is something that the email service provider would do. How can I incorporate this into my workflow? Well, very easily. You could either use a free tool like DKIM Verifier for Perl, or if you're using Python, you could use DKIMPy. Or you could do it manually. If you read the spec, it's actually pretty easy to do the calculation yourself, pull the DNS record for the public key, and verify the DKIM. And while we're talking about these artifacts in the message header that are kind of hard to change, I'm going to talk a little bit about one that is one of my favorites. It's the conversation index. So this is a value that Microsoft uses for email threading. In this case, we're seeing this in hexadecimal format, but you could also encounter this in the message header in base 64 format. What it is that there's a 22-byte header, and then it's followed by 0 or more 5-byte child blocks. So let's talk about why this could be helpful. So if you break it down, it looks kind of like this. So the red part is the header, and the following parts that are in different colors are the child blocks. So this tells me that this looks like an email thread with 4 messages. So there's the parent message, and there are 3 children. If you look at the header and you parse this out, there's a file time value buried in there with pretty good precision, 100 nanosecond precision. So that's the file time value that represents when the base message, the initial message that started the email thread, was submitted. But after that, there's also a GUID. So the GUID is useful because it's meant to be unique, obviously, and this is kind of helpful in a situation where a lot of times when a bad actor wants to forge a message, they start off with a template message. So they take one existing message, they make some changes to it, and then they try to pass it off as a legitimate message. So if you have a message with a GUID that matches another seemingly unrelated message with the same GUID, then that's kind of a red flag. And if you wanted to detect that, then if you're examining a message, you can scan the mailbox and pull out all the GUIDs from all the messages and see if any of them matches your GUID here. If they do, then you would want to look at them more carefully to see why that is even the case. Are they in any way connected, or did somebody take that message and make some changes to it? The child blocks that follow have some time differences, so they give you some idea as to how much time has passed from the submission date of the header message or the sent date of the previous child message, and it allows you to create like a framework or like a skeleton of how that email thread should look like. So we would look at the second child, the third child, and when you put it all together, it would look kind of like this. So there's the header message, there's the first child with a time offset, second and third. And these times are calculated in local time. So that's something to keep in mind. They're vulnerable to time differences. So if a computer's time is a little bit off, then you would see that reflected in those times. And the time offsets can be negative. Which is another reason why you want to look at those time differences, because if somebody's time is significantly off, then that could cause a negative time difference in conversation index. So would I rely on this single-handedly for authenticating a message? No, because there are a few instances where this may not match exactly what you're seeing in the message itself. For example, if you're replying to a long thread, and if you just clear out everything in the message body and start fresh, then what you see in the message body would not match the conversation index. So it's not enough to say this message is fraudulent, but if it is lining up perfectly, then it would increase my confidence that the message is legitimate. And likewise, if it's not matching, then it would decrease my confidence a little bit. So takeaways from this presentation, I want you to think about how to preserve your messages. They should be preserved in the original format or as close to it as possible. So you can do those calculations with the DKIM signatures and the content length. In Jim's case, because those things have changed so much, he could not do those calculations anymore, and he had no way to authenticate the emails fully. It's good to capture server metadata along with the message metadata so you can do a full analysis and acquire and examine in context. So don't fall into the trap of just examining the one message that's important. Always capture it, at least with its immediate neighbors or within the full folder, so you get good visibility into how your message is looking in that environment. All right. Thank you very much.